Hello, I'm Jim Hoxa, and our cosmic address, an introduction to everything. Look up. Above you stretches a vast, silent ocean of darkness, punctuated by the gentle glow of distant suns. This is the universe, our home and the home of everything that has ever existed. On a clear night, you'll see a black canvas sprinkled with countless shimmering stars. Each one is a beacon from the past, its light traveling for years, centuries, or even millennia before reaching your eyes. Each point of light is a sun, many larger and brighter than our own. Some are surrounded by planets, moons, and perhaps even life, waiting to be discovered. These stars are just the beginning. They're our neighbors in the Milky Way, one of billions of galaxies scattered across the cosmos. Our galaxy alone contains hundreds of billions of stars, each with its own story. The universe is everything, all that exists, ever existed, or will exist. Its scale is mind-boggling, stretching far beyond what our senses can grasp. Galaxies form vast clusters and filaments, weaving a cosmic web that spans unimaginable distances. To measure it, we use light years. The distance light travels in a year, nearly 6 trillion miles. Even at this incredible speed, crossing the universe would take billions of years. The nearest star, Proxima Centauri, is over 4 light-years away. That means the light we see tonight left that star before the last leap year. Andromeda, our closest major galaxy, is 2.5 million light-years distant. Its light began its journey long before humans walked the Earth. This vastness is filled with wonders, swirling nebulae where stars are born, exploding supernovae that seed the cosmos with elements and planets of every kind. Some worlds may be barren, others may harbor oceans, and a few might even cradle life. The universe is always changing, expanding for nearly 14 billion years. From the first moments of the Big Bang to the present, it has grown, evolved, and transformed, shaping everything we know. Every discovery leads to more questions, pulling us deeper into the cosmic mystery. Scientists and dreamers alike peer into the unknown, searching for answers about our origins and our place in the grand design. To contemplate the universe is to embark on the greatest adventure of the mind. It invites us to wonder, to imagine, and to explore the infinite possibilities that lie beyond our world. The universe is our shared heritage, the ultimate context for our existence. It connects us all, reminding us that we are part of something vast, ancient, and beautiful, a story still unfolding, with endless chapters yet to be written. The building blocks of everything: galaxies, stars, and planets. These are the fundamental components that make up the vast universe we call home. From the tiniest grains of cosmic dust to the largest galactic clusters, every object in space plays a role in the grand story of existence. The universe is organized like a celestial city with intricate structures and patterns that stretch across unimaginable distances. Each part of this cosmic metropolis has its own unique features and inhabitants. Galaxies are its neighborhoods. Massive systems of stars, gas, dust, and dark matter, bound together by gravity. They come in clusters, sometimes containing thousands of galaxies, each swirling through the cosmos. Our Milky Way is a spiral galaxy, its arms winding gracefully around a bright core. But not all galaxies look the same. Some are smooth and oval-shaped, called elliptical galaxies, while others are irregular with chaotic forms. Each galaxy contains millions to trillions of stars, each with its own story. Stars are cosmic engines, fusing hydrogen into helium and creating the elements for life. Over millions or even billions of years they shine, burn, and eventually die, seeding the universe with the building blocks for planets and living things. They come in all sizes and colors, from tiny cool red dwarfs that burn slowly for trillions of years, to massive hot blue giants that live fast and die young in spectacular explosions. Each type of star adds to the diversity of the universe. Orbiting many stars are planets, worlds as diverse as our own solar system, with rocky Earths, gas giants like Jupiter, and icy bodies far from their suns. Some planets may have conditions suitable for life, while others are harsh and inhospitable. We've discovered thousands of exoplanets, revealing that planetary systems are common throughout the galaxy. Each new discovery brings the possibility of finding another world like our own. The universe is also filled with moons, asteroids, comets, and nebulae. Stellar nurseries where new stars are born, and remnants of dead stars that enrich space with heavy elements. These objects add even more complexity and wonder to the cosmic landscape. Some moons may even hide subsurface oceans beneath their icy crusts, raising the tantalizing possibility of life in places far from the warmth of a star. Nebulae like Orion are birthing new stars, glowing with the light of newborn suns, while others, like the Crab Nebula, are the beautiful remains of ancient stellar explosions, painting the universe with color and energy. The cosmos is a tapestry of endless variety, woven from countless galaxies, stars, planets, and mysterious objects. Each piece adds to the wonder and complexity of the universe, inviting us to explore and discover its secrets. The Grand Tapestry: what holds the universe together? Gravity is the invisible force choreographing the cosmic dance, binding stars, planets, and galaxies. Newton described gravity as a universal pull. Einstein revealed it as the warping of space-time by mass. Planets orbit stars by following curved paths in space-time, not by invisible ropes. Gravity sculpts the cosmic web, galaxies clustered in filaments, separated by vast voids. At the heart of most galaxies lurk supermassive black holes, objects so dense that not even light escapes. These black holes shape galaxies, regulate star formation, and drive cosmic evolution. Gravity is both creator and destroyer, the architect of the universe. Starlight Starbright, the life and death of stars. Across the vastness of the universe, stars are born, live, and die in a cosmic cycle that shapes everything we know. Their stories are written in the night sky, each point of light a chapter in the grand tale of creation and destruction. Every star is on a cosmic journey, born in cold nebulae as gravity pulls gas and dust together. These immense clouds are stellar nurseries where the seeds of new suns are sown. When nuclear fusion ignites at the core, a star is born, shining with energy that can last millions or even billions of years, depending on its size. Stars spend most of their lives in a delicate balance, gravity pulling inward, fusion pushing outward. This equilibrium defines the main sequence, the longest and most stable phase of a star's existence. Massive stars burn bright and die young, living fast and ending their lives in dramatic fashion. In contrast, small stars like red dwarfs burn their fuel slowly, glowing faintly for trillions of years, far longer than the universe has existed so far. When a star's fuel finally runs out, its fate is sealed by its mass. The next chapter in its life depends on how much material it has left. Sun-like stars swell into red giants, their outer layers expanding and cooling as the core contracts. These stars shed their outer layers, creating beautiful planetary nebulae that glow in the darkness, leaving behind a core of pure carbon and oxygen. What remains is a white dwarf, a dense hot ember that slowly cools over billions of years, a silent witness to the star's former glory. Massive stars, however, end in spectacular supernovae, explosions so bright they can briefly outshine entire galaxies and be seen across the cosmos. These cataclysmic blasts scatter heavy elements, oxygen, carbon, iron, and more, across space, enriching the interstellar medium. This cosmic dust and gas become the building blocks for new stars, planets, and eventually, life itself. The collapsed core of a massive star may become a neutron star, an object so dense that a teaspoon would weigh billions of tons, or, if the star was truly colossal, its core collapses further, forming a black hole, an abyss from which not even light can escape. The life and death of stars forge the elements that make up planets, oceans, and even the molecules in our bodies. We are quite literally made of stardust. Our atoms born in the hearts of ancient stars. The story of stars is the story of us, connecting humanity to the cosmos in a never-ending cycle of birth, death, and rebirth. For most of history, we knew only the planets of our solar system. That changed in 1995 with the discovery of the first exoplanet orbiting a sun-like star. Since then, thousands of exoplanets have been found, hot Jupiters, super-Earths, even rogue planets drifting alone. Most are discovered indirectly by watching for tiny dips in a star's brightness, the transit method, or subtle wobbles, radial velocity. The ultimate goal to find habitable worlds, Earth-sized planets in the Goldilocks zone, where liquid water could exist. Future telescopes will analyze their atmospheres for signs of life. The search for other worlds is the search for cosmic company. How did it all begin? The Big Bang Theory is our best answer. About 13.8 billion years ago, the universe began as a hot, dense point and started expanding, space itself stretching everywhere at once. Evidence comes from Hubble's discovery that galaxies are moving away from us, and the farther they are, the faster they recede. The cosmic microwave background, ancient light from the early universe, confirms this explosive beginning. In the first minutes, the universe forged hydrogen and helium, matching what we see in the oldest stars. The Big Bang explains the universe's expansion, its chemical makeup, and the oldest light we can detect. Our cosmic story began in a single moment, and everything since has been shaped by that event. The universe is a record of its own origins. We are part of that unfolding story. We see stars and galaxies, but most of the universe is invisible. Galaxies spin too fast for their visible matter alone. Something unseen, called dark matter, holds them together. Dark matter makes up about 27% of the universe, forming invisible halos around galaxies. Even more mysterious is dark energy, discovered in the 1990s when astronomers found the universe's expansion is speeding up. Dark energy acts as a kind of anti-gravity, making up 68% of the cosmos. Ordinary matter, everything we know, accounts for just 5%. We live in a universe dominated by the unknown. Unraveling dark matter and dark energy is one of science's greatest challenges. The cosmos is mostly mystery, with us as explorers on a tiny island of light. The quest to understand the dark is just beginning. Are we alone? With billions of planets in our galaxy, life elsewhere seems possible. SETI, the search for extraterrestrial intelligence, listens for signals from other civilizations using giant radio telescopes. So far, the universe is silent. This is the Fermi paradox. If life is common, where is everyone? Maybe intelligent life is rare, or civilizations destroy themselves, or the distances are simply too vast. If we're alone, we bear the responsibility of being the universe's only way of knowing itself. If we're not, discovering others would change everything. Either answer is profound. The search continues, driven by curiosity and hope. Why care about distant galaxies or cosmic history? Because the universe gives us perspective. We live on a fragile world, a pale blue dot, in a vast ancient cosmos. The iron in our blood, the oxygen we breathe were forged in stars long ago. We are the universe made conscious, connected to the cosmos at every level. Exploring the universe drives science, technology, and innovation, enriching our lives on Earth. Curiosity and wonder push us to ask big questions and seek new horizons. The universe inspires awe and humility, reminding us of our place in the grand scheme. There is still so much we don't know about dark matter, dark energy, and our cosmic origins. By looking up, we learn about ourselves and our potential. The journey of discovery is far from over, and it's a journey worth taking. Jim Haxa out.